So about the collisions, we are performing some collision checks in the sequence, this exact same exec perform collision on objects. So we have some function where we can put what we are asking for and what kind. For example, we can check for anchors or for info or for pushback. As we have in the sequence, we are asking only for pushbacks. Or whatever we like. We can choose any. Let's go to the collision check itself. So first it is checking if reference line for detectors are loaded. And if not, it is checking anim stack. So given animations cycle, and is checking if there are anything to load, just to be sure. Obviously, if everything is going correct, he doesn't have to reload anything, but let's say it has, there is exception handling for this, and he's gonna push detector stack from the correct animation. He's checking which animation it is and so on, automatized. Okay, so if there are detector lines, he's gonna calculate them. So calculations are performed here. Here is a forced precision if there is, and here are those information we have sent here. So what type we're looking for, what the name of detector we are asking, and if we're forcing a precision. We can force another precision that it is in use. So override this number of collision precision 5, resolution 5. We can override this number just in the code, but I didn't find for now any reason to do that. So the format is, for example, info and name of the collider, or any gonna return us all the collision lines, or as we did here, we can ask anchoring, or we can ask for pushbacks, or whatever. So if he found any line with this criteria, he's continuing check and finding points where this line is from to, and checking its word position, labeling it correctly, what path, what reason for check, for example anchor or whatever, and is checking against the geometry. And for now we have turned it off fast check because we are chunking directly on the world map. Okay. Else we can use other kind of reference. What is the point of this? Let me see. Okay, fast check perform, it is one of the optimization. It did almost nothing in most cases if the terrain is very dense, but if I do some normal level, like not packing a lot of geometry for colliding all around, it's gonna work differently, so it's gonna make some savings. For now it is just torturing memory because the file of the collisions is too big. So swapping in this file is pointless. So here we have a collision to return. As for starter, it's empty. Length of our line, multiplier by precision and length and stuff. So we are splitting our line in small parts by the precision, and we are checking every part of this line. So this is why precision 5. And we are checking which arrays on the map we are to refer. So what chunk is to be checked with triangles, because all geometry is chopped into chunks. So here we are grabbing from vertex buffers and it is chunked. This is the same function as we have here to check it. So we are loading some chunk and then we are checking triangles in this chunk, and triangle after triangle we are loading it. So triangle to check, and here we do calculation. For now it is static because we are checking static terrain, static collider array. So this one is for static. It has no point for now and other than existing. This is optimized version which do nothing special, it even work slower. So it didn't help to optimize it. So we are loading our triangle, so triangle point 1, 2, 3, barycenter. It is not a barycenter, it is just the middle of the triangle by those 3 points. And triangle point normal, and we are checking if our line is on different sides of the triangle. So we do some math. If our cast of the normal vector of the triangle is positive and negative for 2 points, if their sign is not the same, so we are on different sides of the plane on which the triangle exists, and then we are checking if our position of the point is in the triangle area. So we are calculating dot products from our triangle points from one to another to collision points. So collision to every point of the triangle, and we are summing dot products from one line to another. We are about to get 180 degrees around because the collision point is not exactly in the plane of the triangle. Obviously it will be almost impossible to get it. So we are summing it, we get some results. So we are adding dots, -3. Sum of our dots should be -1. So full cycle, like triangles have 180 degrees, and if our dot product is less than -4 after this operation, so it is at least -1, it's good. It's good. Same for second point of the collision line, and if any have returned a collision, we are returning a triangle hash. So what object it is, collision type of the triangle, which can be solid or something else like slowdown, and we are pushing collision. So collision happen between point 1, point 2, triangle normal, triangle hash, what kind of vertex buffer, maybe I'm passing information, probably it is a part. What kind of geometry, so we have static here, and collision type, it is, for example, solid collision, and we are returning it. So we are stacking all the collisions and it is returned back here, and we are pushing it in the object part detector lines, so we know which line have returned it with point back, and we are returning our object back after tortures to the function perform collision, and perform collision is returning, for example, here. Then we are checking if there are any collisions for the anchors, and here we are checking if the reason for check is filled for any collision found. If so, yep, we go for it. Of course, we can check for any reason. Like if any reason, all goes. There is some collision. And if there is no anchoring collision, we go forward with animation. Else, if there is anchoring, we performing simple anchoring. We just checking which collision line is correct. Here we have collision, solid, for example. We are checking gravity vector against our walking dot product. It should be 30 degrees. It is set to 60 because I don't have climbing animation or like passing hard terrain. So we are, in case it is lower than walk dot product, it is doing nothing and is performing anchoring. Else, if it is higher, it is switching ground stay to idle or something like that. And is showing those information we have on the left part of the screen because it is the part I'm working for now, with switching animation to walking hard terrain. In case of idle, also doing something, so there are some issues with colliding with walls. So he cannot stack in the walls that have a dot product against the gravity higher than walking, and I can flow through the walls that way in some cases. So I'm stopping on the wall, I cannot anchor, and idle animation if it checks that there is no anchor. So I was just jumping. He will throw me to the fall, and if there is no ground under the wall, so I'm passing through the map and I have to respawn. Okay, so we are adding anchor. So object has some control method anchor, and our anchor, which is position and related part, for example feet, will be connecting us to the ground. So we are resolving again if we are switching to the next feet, because walk cycle from the left feet, if hits the ground, we switch it to the right. So we are back in our behavioral cycle resolving. Let's go to the walk. And if he was walking, he's switching the letter of the walk cycle. And then, because we have anchor, we are moving the main object by relation to the anchored point. So in case there is no anchor, it is doing nothing, just return object. Else it is moving the position. So different between expected anchor position and so on from the chosen anchor. So he's moving us to the correct place in the world space. And at the end we can resolve some controls. So it is checking if action is press or yaw, so if we are turning or if we are going or whatever, it is switching camera, moving it around, and all the fun stuff. Go, jump, move, speed up, and it is handled here. So in general it is switching some cycles in case, or moving us to jump, and jump will be interesting. It is checking if we are in idle or walk mode. It is the first kind of jumping I have implemented. He's checking if it is reasonable to jump. So he's calculating how far we press the button and how far it's gonna jump. And it's returning some values like up, forward, and sides. Same for jog, just the check is done in between steps if he is anchored, because when jogging we are not always anchored. So instead of jumping in jog, he's performing much longer jump, but later on it is returning jump vector against position matrix, against multiplier, and against the gravity. So here we have the cast of our acceleration up, so jump vec up against gravity, jump vector. Our jump vector is against the gravity vector, and we see if it is jump. If our acceleration is greater than 1 or 1 after flooring, so if it is 0.9 g of the jump, of course we are not about to leave the ground, so our acceleration must be higher than 1. So after flooring we see if it is jump or not, and if it jump or not is greater than 0, anim info is returning our jump vector to not calculating it again. So we are holding the jump vector until the position we're gonna jump. And here is some debugging from the past. So in case of walking or idle state, we perform jump directly. So it is switching the animation like now, and is resolving behavior. In case of jog, he's just keeping this information and resolving it in the behavior. So later on, when he's be switching when he touch the ground, he gonna start cycle. So let's go there. So we are going to the jog, and there is a jog 1, jog 2, jog 2, and here we are resetting translation, so jog 3 is landing. Okay, so jog 2 is flying, and if we go to the jog cycle, if we switch to jog, this force is executed here. So jog 1, checking if it is reasonable to jump, and executing jog 2. Else, if it is not reasonable, is switch to walk. So you are not jumping enough. It is very important because we can run or jogging too slow, like if we leave the controller and leave it free and it is slowing us down, so we're not pressing forward. We can lose speed, and by losing speed, the jumping in jog itself, so when we leave the ground, will be not enough to lift us, and so it's reasonable to switch back to walking. That's the logic of slowing down in this game, like in this engine. So it is how it is resolved, and as we see in the gameplay, it works. I have still some issues to fix, like ghosting through the walls, because for example, if we go to the idle, to not be hanging on the walls, if we have no anchor, we switch to falling. However, we are not anchoring to the walls that are more than 60 degrees from the ground. So sometimes we can just hit a ground that is 70°, stop there, and no, we cannot hang there, we fall, because there is no climbing for now, and I need to fix climbing. That's the reason why.